All right. How's everyone doing today? It's a big audience. I'm not used to this, so give me a break here. So what I'm going to cover today is the top 10 most common Java performance problems. And one of the things I added at the very last minute is I actually wanted to bring you some, actual customer examples. I'll tell you a little bit more about myself in a moment. My name is Mykhaylo Shaforostov. Everyone calls me Mick, so I encourage you to do so as well. I joke around, if you can spell my name completely exactly, you get a 15-day trial of our software. Actually, it's available for 15 days trial anyways. So, a quick introduction about myself. So I'm a software engineer by trade, although by my suit you may not be able to tell that. I promise I was at a bank customer today, and my VP of sales was around, so I had to look the part. But I am, a software engineer by trade. I went to Queen's University. I took Canada brackets, unless you guys don't know where that is, but also because I made pepper you with A's and a boots. So give me a break for that too. I started developing at Nortel Networks. I used to develop media gateways and unified communication systems. So what I used to be able to do is combine voice over IP software with GoToMeeting, WebEx type technologies, as well as chat and multimedia into kind of one unified communication system for tracking and for everyone to collaborate on. The challenge with that is all of these different technologies have to communicate together, and we had to figure out a way to bring them and make them work. It was a late stage development, so I wasn't really developing them from the scratch, but what I was trying to do is actually try to make them talk and perform well. So out of that, if you guys don't know, Nortel Networks is no longer around. It went downhill pretty quick. I was not at fault, I promise that. Although I did walk in once into a server room and I started swapping servers, and apparently there were customer servers, and I also didn't have any static training. But I don't think that's why they went down. But after that, I really got the knack for performance. I really enjoyed that part more than programming. So one of the things I kind of started doing is I went and I joined a small consulting company to work as an application performance consultant. The reality is I actually worked with many different tools and solutions, and my role was to actually help the customer try to figure out, optimize their software, find things that they could optimize. And in doing so, I found out about the company that you obviously see plastered everywhere in my slides, and that's AppDynamics. Has anyone heard of AppDynamics? Oh, excellent. So, and for the rest who haven't heard of AppDynamics, do you guys know about the space called APM, Application Performance Management? Okay. All right, so some of these topics are going to be quite familiar to some, but I kind of like to cover them because, quite frankly, the top 10, as I'll talk to you guys about, why is it only just top 10? It's actually 8, I lied to you, sorry. Nobody wants to do a presentation of top 8, right? So I had to pad my presentation with another 2, and you'll see why, and I don't know that stuff. But in most cases, in my experience, application performance problems really boil down to at least 90%, in my experience, to these top 10, right? They may not be the reason why you have a problem, but it certainly will help you isolate or remove at least the doubt that they are the case. And really, they sometimes could be leading indicators to performance problems happening next. So it's important to at least know them. They may be common sense to you most, but I like, as common sense, Voltaire said, common sense is not very common. And I need to remind myself too what some of these are. Okay, so don't read them just yet. Leave some surprise there. This is, by the way, this is based on an ebook that was written by a colleague of mine. So I'll explain to you how some of these things came to be. Clearly somebody already stole the other 4. I have one paper copy. But at the end of this presentation, I'll present to you the link where to get this ebook. It's going to cover all these topics in greater detail than I can in 45 minutes. Okay, Frank, nobody go there right now, but I have some swag. I've got some glass cleaners and pens, and also how to find, download the software and play around with it. The top 10 Java performance problems, as I see them, really boil down to 3 categories: database, memory, and concurrency. And the last stuff I have to pad around. So let's jump into it. So before I go into that, 4 steps to problem resolution. How do you do that? In my experience, and what I normally do is I first have to identify the problem, and one way or the other, using one tool or the other. You have to identify the problem. You have to understand the symptoms. You have to start troubleshooting one way or the other, right? And whether it's production or pre-production, you have to go back into development and try to reproduce the problem. But ultimately, you have to fix the problem, remediate, and obviously manage it going forward. You want to make sure it doesn't happen again. So let's start with database. And I love examples. All right, can you guys see that?
Yeah.
A little bit. All right, so I'll explain to you what happens here. So this is a particular transaction, a real user transaction in a real user environment. That's why you see all those blurry things over there. It's in one transaction, it's executing 76 SQL calls. And at the very top, there's a SQL select statement that on average takes half a millisecond to execute, but it takes a total time of 5.5 seconds to complete. And the reason for that is, if you see there, it actually is executed 10,000 times. So the very first topic I'm going to talk to you guys about is the death by 1,000 cuts, the database N+1 problem, right? So individually I created, it takes a little time, but because it's executed many times, because of that, the nature, it's going to have a bigger impact on your application. So the symptoms of that, as you saw just earlier, it's hard to detect under small load, right? It typically requires a situation where there's high load and there's stress testing, or sometimes a production environment when the user does something weird. So the way that you can troubleshoot that is you do have to find a correlation between a particular user interaction, what they were doing, and the number of calls that that particular transaction is executing. You can do it in various different ways, but ultimately you do have to count and aggregate the timings of each one of these transactions. Typically, if you understand, if you have a persistent layer, and typically even within a persistent layer, you're going to run into some problems. Because if you don't know, or you haven't really looked at the configuration of Hibernate, there are two different strategies for how to make sure that your persistent layer works for your requirements. And so you have to figure out whether or not using eager versus lazy fetching. And depending on user requirements, you might use one or the other. The other thing that you obviously need to do is optimize the business logic. If it's code that's not executing properly. So in that case, by the way, we found that the problem was, it was actually a legitimate transaction, right? It was a user trying to load a whole bunch of things to warm up the cache, which leads me to the next point. Having a good cache will definitely help you optimize and remove some of these problems. Now, speaking of cache, right, the importance of caching, and this is kind of probably obvious to most people in the room, but if you have no cache, that's an easy optimization spot right there. That being said, if you have misconfigured cache, you're just asking for trouble. So make sure that you have a configured cache. And the other one is if you have a distributed cache, it's all great. It's fantastic for complex and distributed web applications. But if it's not consistent, then you're going to have a problem as well. And that introduces some more complexity in that. So symptoms are going to be slow response. And like the N+1 problem is that your performance is going to be fairly gradual. So all of your transactions will be affected by the fact that your cache is not performing well. And it's going to be fairly slow degradation in performance. So in order to understand how your cache is working, typically we track GMX metrics, cache hit, cache miss, and use those ratios to understand how your cache is performing. It's going to be very useful into troubleshooting any problems with the cache. Now, I went to a little bit of debate with some people. Does caching make sense? There are some cases where it doesn't, but again, that was a debate I didn't want to fight because it's been a while since I've actually had to develop. But the most important thing is you just ask yourself, if you face a performance issue, is this something that can be cached? But just don't over-engineer things is basically the advice I give. And that's the advice I kind of give for most complex applications. I typically deal with SOA architectures where there's a lot of different components, and I do like the KISS principle. You guys all familiar with that? Okay. This is one of, and these examples are real customers. Again, it's really cool stuff. It's always nice to be able to show these kind of things to a customer in their environment, especially when they call you and say, I need some help. In this scenario, what you'll see is in blue, it's our the top amount of connection pools, so the maximum amount of connection pool, which is set at 50 in this case. And the green line is the current utilization of the GBC connection pool. So as you can see, in some cases, we're actually hitting 100%, right? So what happens when you hit 100% of the connection pool, right? Does anyone have a connection pool I could borrow, right? Database connection obviously are expensive to create, so create a pool to reutilize them. And there's a good reason for that, right? But since the database is shared, we want to make sure that we have it sized correctly, and depending on the amount of applications that access it, we need to make sure that we have that number set right. Too small of a pool, what you'll notice is the database is probably going to run without any problems, but the application might start having a problem, right? If it has too many requests, you might run into problems there. Or you might have too large of a pool, and someone says, well, you can't have too large of a pool. Why is that bad? Well, for the application, it's really good. But then all of a sudden, your database is going to get overrun. And the difficulty on this, right, is how do you determine which way you're biased? If it's too many or too few. One of the things I've found in my experience is that if you see a data source dot connection, that means you're biased towards small connection pool. Whereas if you see a prepare statement dot execute that's taking long, that means you have a large connection pool, right? So if you're trying to get a connection and you can't, that means you're out of connection pools. If you're trying to execute your statement and you're waiting, that's the other part. So the remediation strategy, I mean, that's a tough one, right? You obviously want to optimize your queries in your database, and you do want to stress your application to understand where the bias really sits, right? I'd say it's a science, but it does require a little trial error. I mean, ultimately, when we test things in development, everything looks good. We have all the great hardware that we want to put at it, and usually problems don't manifest themselves until you go into a production environment or under stress where users are doing different things and your little patterns are going to be slightly different. So plan and monitor over time. The next things I want to talk about is memory. That's a cool topic. All right, how many of you have seen this memory pattern in the Java heap? Oh yeah, good. Everybody. The infamous jagged tooth memory pattern, right? What's interesting about this is in this particular user case, it was happening every hour, which was the first thing I sniffed was kind of a problem. I mean, why would it happen exactly at every hour? It was actually a cron job they ran to run garbage collection. I don't know why they were doing that. My job is not to judge you for what you're doing, but to help you identify and showcase how you do things. And by the way, I mean, none of these guys are, these are very intelligent developers. It's just they're very busy developing the next generation of things. So some things kind of remain in the background, and only when the next wave of marketing campaigns hits the server, and all of a sudden all these things appear out of nowhere. But here's another interesting thing that I found when I looked at these guys. What does garbage collection really mean, right? This is a graph of garbage collection time spent, and you see there's a lot of time spent into the green bar, but also graph the overall average response time for the users connected to this application. And you can see that it's kind of hard to see, but it's about 4x. Every time there's a garbage collection, right, your average response time jumps by 4x, right? If you're a web application, if you're dealing with customers like e-commerce, all of a sudden it takes 4 times. That's pretty bad, and it's because of a garbage collection. I mean, that's not good either. So the next topic is I'll stop the world melt with you. Stop the world garbage collection. So the problem, major garbage collections are normal. It's part of the execution of your application. But if they occur for too long or too often, or they're predictable in that case, you might have a problem. And we all know that it's a stop the world condition unless you have some other technologies in place. But typically, it's a stop the world condition that's going to freeze all your threads, and that's why your performance is going to degrade. Symptoms, usually it's a CPU spike. That's the first thing that you'll notice. I mean, I've had the luxury of having additional metrics to look at. When you see a CPU spike for very little time, typically that's garbage collection unless there's something else going on in the system. And obviously your transactions can slow down. People are going to start noticing there's some problems. So troubleshooting they can do without really any tools is, and this is a painful one, is enable verbose GC and search for flags for full GC. That's the poor man's way of finding out your garbage collections. Maybe you have Splunk or something to start searching for them and make it understand what's going on.
Here.
Sorry?
You missed a column. It's verbose column GC. Thanks,
Vitaly. I was like, I recognize that guy. Thank you for that. I'll update the slides. Or you can use an APM tool or a profiler, whatever works for you. But at the end of the day, you do want to, monitor the number of GC, time spent, and all these patterns of increased memorization to see if there is that jagged tooth problem, and really ultimately find out if that's going to, slow down your transactions. The remediation strategy is pretty straightforward. Is size the heap appropriately. That's a simple one. Like I said, I've got an ebook here. Not written by me, but a really great guide that works for us. It's free, and you can see some of the recommendations there, or you just Google. That's what I do. Does anyone else feel like without Google, I don't know, I find it I would not be good at my job. Huh? What's the name of the book? The Top 10 Java Performance Problems. Yeah, I was very original with my naming of this presentation. I mean, obviously the other things, enable concurrent market suite, and the last two, they were from the guy who wrote the book. I do not know how to speak to those. So I take it for what it is. I'll have to find out myself what that means. I've never actually done any of the latter two. I usually look at the size of the heap and adjust the different memory pools and do, usually do the old school type of remediation. So, all right. You guys familiar with this example? Utilization rises, there's a whole bunch of garbage collection, and nothing happens. Well, this is a more difficult topic. In this particular case, by the way, they also run out of Chrome Gen. This is, moments before the JVM goes, which is fun because this was happening on hundreds of nodes, but only one at a time had this problem. So we basically had to enable this and find out what's going on. And memory leaks, I can't very easily talk about this because it's really hard to find and determine a memory leak, right? That could have been totally part of warming up your application server, right? The users start using the application, your memory goes up, it's totally fine, you're using up your connection pools, and that's typically normal. But in some cases, that could still happen. And it's funny, I always have this conversation when I used to develop the original switches that we used to do with C++, right? And so you have to, actually some C, where you actually have to, make sure that you don't have memory leaks. But, in Java, unfortunately, what happens is, bad code still exists, and that's why you can still run into these problems. The symptoms are pretty straightforward. You gradually increase the memory, and you run out of memory. But like I said, it's hard to differentiate between real load and all that. So for that, you really need to start focusing your attention on different collection classes. Start tracking if there's object thrashing. Look at your map list, hash tables, trees. Just see if there's an increase in utilization over time that doesn't get cleaned up, right? And then obviously use other parameters like load, number of users using your application, and other things to map them against each other and see if there's really a real problem there. The one that I don't like is you force a heap dump and analyze the objects and find out if don't do that. That's painful. Remediation strategy. Obviously I'm a little biased, but continuous monitoring and tracking is really the only way to maintain that, because when it does happen, it's going to happen out of the blue. You just want to have that information available to you to what led up to it, so you can actually diagnose it. Or you could just do a heap dump and good luck with this stuff. All right. My next topic is going to be concurrency. I don't like when this happens. JVM deadlock detected. That's going to be a tough topic. Sorry, was there a question? Which one? Oh, you like
Hot Fudge Sundays.
Have you heard of this before?
No, I just like Hot Fudge Sundays.
Okay, so, and I do need to stop and actually explain this. So I'm really following the ebook as well, and if you're ever in a situation, where a significant other or a friend who doesn't speak Java, and you start talking about thread deadlocks, I don't know why you would, but in the case the situation arises, bring it in the following: Hot Fudge Sunday standoff, right? Which is when two stubborn kids, one has an ice cream, the other one has a fudge, and neither of them wants to share. Neither of them are going to have the hot fudge sundae, right? Which, when I said it to my friend, she says, well, what if I just go in there and do it for them and just eat it in front of them? I said, well, that's not how JVMs work. And then she says, what is a JVM? And I said, this is not a conversation I want to have right now. So, but you can use that in the future. So the problem is when two more threads want to access the same resource, right? And Java this occurs when there's synchronized code block. The symptoms, this is an interesting one, right? Is In a web application, really it means that less and less resource available, so less and less user can use the application. All of a sudden you have a node where a user is trying to access it and nothing happens. And you look at the CPU utilization, memory disk I/O, everything is great. From an infrastructure perspective, everything is great. Your memory utilization and JVM is also really good. So what is going on, right? So to determine these and solve deadlock, you typically need a thread dump. And those are painful to look at, but that's one way of looking at it. And what's really harder to do is actually determine the conditions. I mean, if you're really good at reading, and typically in new modern servers, there's like 500 threads that you have to look at and search for. So it is pretty difficult to determine. You saw that screenshot. I mean, again, I work for a company that magically shows that kind of things to you, so it's easy. But without that, there's other ways to do it, which are a little bit more complicated. The remediation strategy that I usually say is, use the thread synchronization sparingly. That may not be possible. A lot of applications that we leverage, especially in solo environments, are commercially off the shelf, and you might not be able to modify that, so you might have to live with it. Or you have to, call Oracle, and hopefully, 2 months later, that's going to get fixed. Nobody from Oracle here? Sorry. Or monitor for deadlocks. Another typical one is, you get burned by a, you might have gone burned by deadlocks, so you get to the next stage where you try to be very safe about it, and you end up single threading multiple threads through one synchronous code block. So now you have a highway of cars trying to go through one easy pass lane. So typically what happens, again, you have high thread utilization but low CPU. So you look at thread utilization, active threads, looking at the load, and see what's happening from a performance perspective. Or you can go into thread dump and just count the number of waiting and time waiting. That's another good way of looking at it. There could be another condition that could lead to that, but I'm trying to keep it simple. So the troubleshooting will be to follow execution of individual transaction and periodically take thread dump. That's what I typically do. It's a hard one to do. I mean, if you don't have access to the code or a developer that understands the code, it's going to be difficult. By the way, I mean, a lot of these things that you're going to notice is you're going to require somebody smart at the end to help you fix it, right? All this is helping you is how to get close to the problem resolution, but it's not going to solve the problem. Which I call job security, by the way. Again, remediation strategy is similar to deadlocks, and with a clear understanding of how a transaction works, that might actually help you. And then sometimes you have to just re-architect your code. There's no easy answer for that. Right.
Here's a question.
Yeah.
Does this 2 bus, like 6 and 7?
Yeah. The hot fudge.
Problem. Do they apply to the latest versions of Java, 8 and 7?
I believe 7, yeah. I'm not sure about 8. I'm not very familiar with 8. Yeah.
I mean,
Yeah,
it has been working on file libraries, and they are getting better and better. And
Yeah.
I assume like they can do it.
If you are using libraries, they usually can, but if you do synchronization by yourself, you can easily get into this on any Java.
But it doesn't matter. The principle of syntax is that if you arrange indices in wrong order, you will get deadlock. It's not specific to Java or any particular operating system. Is that if there is a mutex, and if there are actually 2 mutexes, there is a possibility of deadlock if the code is arranged.
But the latest file libraries are more sophisticated.
Well, not
They
one.
have like specific solutions for that one.
You should follow the patterns. There are very easy patterns to avoid deadlocks. Like take the logs in the order. It's a very good pattern to avoid deadlocks. Or better, not log yourself. Just give it to some library. Give it to some application server to call it. This way you will be more safe.
Or use non-blocking returns. But then there are no actual blocks. There is synchronization.
Asynchronous, like.
You might want to hold your question until after Ben speaks.
Like,
Why don't you hold your question until Ben speaks so he can address some of that stuff?
okay.
That's pretty cool. Or you can use Node.js and use an event loop. Whoops.
And still you have a database, and you can have the same entity.
I still got it. Thanks, man. He's looking out for me. Thank you. This is a really cool. This is a cool example actually. I ran really recently at a real company that. They're all real companies, but this one in particular was a web company that is very dependent on second-party resources. So when we walked in there, they had a big problem. They couldn't quite figure out what the problem was. And what you see in blue is, which one is that? Infrastructure. In blue is the number of threads. Oh, it's so hard to read. Okay, yeah. So in blue you have the number of threads, right? Yeah, and okay, I got a map for it. The green one is the current number of threads, which spikes, and the blue is the response time. No, actually, I got it backwards.
Overall application performance average response time, and those seconds in the blue is the current number of threads.
It's awesome, thank you. It's my own slide, I can't read them. Yes, so what happened here is we found that we hit the maximum number of threads, and that had a problem with the average response time. So what we then did is we actually looked at a couple of other metrics. We found there is this backend or dependency, it's a web service, it starts with G, ends with E, that for whatever reason, typically they're really, really fast, sub 100 milliseconds. And this one day, you see the green spike, it went really high. Now, they had a dependency on that, right? So they have traffic coming in on the left-hand side, they do some processing. On the right-hand side, they query G, OOLE. And the stuff that returned back took a little bit longer. So you can imagine it's a queue, right? So you have the exact same amount of users coming in. So they said, well, it's not a DDoS attack. There's not that many users coming in. But they didn't notice that just a few milliseconds of latency on this backside, what ended up happening is they started using up more of the threads just waiting, right? And so what happened is there's a leading indicator. So remember, a lot of things I cover, sometimes it's not going to be the resolution or the reason for your problem. But that leading indicator right there is just before the blue line, which is where your performance degrades, right? So at that point in time, you used up all your threads, and all of a sudden the application can handle additional load. So we call that, thread pool configuration issue. And it's not really an issue. It's just the matter of fact is that you can have too small of thread pool configuration, which means that your transaction will be waiting. Or it could be too large. I mean, again, why is too large ever a bad thing? Well, when they changed it to too many, all of a sudden they fell off the permgen and the thing went down. So you do have to, again, figure out a sweet spot, especially when you're doing a lot of these stress and load tests to find out where your application really belongs with some of these parameters. The symptoms obviously is the thread pool utilization is really high, especially the ratio is up to 100%, and your transactions start slowing down. Users start complaining. That's really typically a good example of that. The answer to that is you have to track this metric. You have to track synchronization, and in some cases you have to track the response time and then track it against each other, right? And just figure out where it comes. Yeah.
Quick question. How are threads spawned? Fill up your permgen?
So, because they use up the metadata, right? So every additional thread puts some metadata in permgen. Am I wrong about that?
I've looked at the code. I'm not sure if that's true.
Okay.
There are some strings which are generated which could potentially go in permgen, but permgen is non-existent in Java 8 anyway, and generally speaking, you will run out. You can maybe spawn 50,000 threads on a Linux kernel finally too, but that number is not going to affect your permgen.
I'd say it would affect your heat because your transaction.
Yes, absolutely.
Yeah, if you have 40,000 running transactions,
Yeah.
each one has its state. And if it's like 2 megs of state, you can multiply.
And most likely you'll run out of stacks.
No, no stack.
Well, no,
Well,
every
where does the
thread
stack
takes
get
a
it?
stack, and if your stack is high enough, you'll actually run out of
Virtual memory in the operating system if it's limited.
That's true, but it's usually
Okay. I could be wrong about that. Usually I look at those metrics and see, oh, this goes up and permgen goes up, and I figured the two are related. So I'll fix that for next time. So you said Java 8 doesn't have permgen?
no.
I'm really out of date with Java 8.
They have some other material problems.
They moved it to the regular key.
Yes.
Oh, okay. Okay. Probably better. I don't know. So remediation strategy is all about the sizing, and watch out for for the heap size, right? When you make these changes. So I may not be wrong with Ramjan, but I think if you have too many threads, you're going to use up more memory. So it's important to track that metric anyways. Too large again is a problem, too small is a problem too. So again, it's always about finding the right balance and understanding how under typical conditions, and sometimes not just purely conditions that you can reproduce in load tests, on stress tests, but also real world conditions. And users are doing some weird stuff. On the website, they go and try this and they hit refresh too many times. So all those conditions can lead up to some of these problems you may not predict in some of your test suites. All right, so a little bit of filler. So there's really only 8. And because I work for this company, I had to tell you about a little bit of what we do, right? And I mean, the reality is, I think I'm in the space, APM, it's a growing space, and we do get some feedback back saying, oh, we don't need application performance. And to me, performance is not really a one-time thing. You check it, everything's performing well, and then you're good to go. It's an iterative, ongoing process, right? So you need to have, whether it's us or anybody else, you need to have a tool that helps you understand and track these metrics so you can make better decisions based on that. And really, I said this right, is typically in pre-production you have everything under, everything is under control, and then you go into production and you have problems, right? Users do weird things. Users will change it, will change the course of how you develop your software. Your new features might be addressing something that a user complained about. So all of that is a feeding loop, right? Every time you make a code change, you want to make sure that your application is performing properly. And you definitely don't want to rely on logs when things go down, and rely on your users calling you in and say, oh, I can't do this. And when did you do that? Oh, I think yesterday. And what exactly we were doing? I was logging in. Okay. So it's hard to rely on your users to figure out what the performance problems were, right? And typically by the time you get there, it's pretty bad. So, I mean, at minimum, always think of performance during development, and ideally make it part of your development lifecycle. I don't think that I'm making anything new or crazy here, but performance-driven programming. Develop to make sure that performance. You keep that in mind every time you make any changes. Yeah?
Why did you make it number 9?
This one?
Why did you make it number 1? So that's like 95% of all the problem. And the other one, like 5% of the 5 guys that I studied. This is very ridiculous.
Yeah.
All performance has to do with the fact nobody wants to do performance.
Yep.
Nobody wants to do anything. They just want money to go away. Just take the program and let it drive.
Yeah.
And get performance.
Well, I mean,
The function is like it, so what do you worry about performance? So it's 95% of the problem.
you're right. I mean,
Everything else is just, small vegetable. All the other ones, it's just unique stuff that is applied to people who like us,
well, I was hoping to make a presentation for you guys. Otherwise, I'll go into my demo and show you how cool our product is, and I'm excited to do that. But I mean, a lot of these speak to me. And I mean, performance is a big thing in my career. I think of performance all the time. If I wasn't doing this, I would be doing something else involved with performance. I'm very passionate about it. But yeah, you're right. I mean, performance should be number 1.
Solution is infrastructure because it's the same everything, right?
Sorry.
Performance, the solution to performance is infrastructure because it's structured. Nobody cares about performance. Then it doesn't work well. Then you sell more hardware, more licenses. So actually performance should be bad from a vendor perspective.
Not for us though, because we actually want you to optimize. So one of the key things I usually talk about in terms of optimizing your performance is I want you to use less hardware, right? I want you to make sure that you utilize that machine to 100%. You run it as hot as you can, handle as much load as you can. We don't care about what we run, right? What we care about is that within your application, how is your application performing? Collecting this information about the metrics.
I don't suspect you as a vendor.
Yeah.
To sell the product.
Amazon wants to.
I suspect the hardware vendors, the
Oh, yeah.
software vendors, they say, why do you fix performance? Just buy our stuff. You get $1.
Yeah. And I mean, Amazon or any cloud provider wants to make sure you spin up as many images as possible and charge you per second, right? So, yeah, I mean, that's why this is why this space is exploding for us, right? There's a reason why we've got to where we are, is because we're really giving savings to anyone who's trying to lower the amount of investment doing on hardware. And also a lot of times when you run into problems, you try to solve them. If you don't have the information to help you realize it, then how are you going to do it, right? Which leads me to the last point. Again, maybe you're right. They're the top two, but I didn't want to pander. Monitoring is super cheap. Just wait until a user calls in and tells you I couldn't do something. So, I'm a believer that there are no solar flares. Although typically I go into some environments and someone says, "Well, look at this spike. It happened once, and it can never reproduce it again." Well, I think that that could be an error with the application. It could be a code level issue, and that's where I involve the developers. But when we talk about performance, performance always has some leading indicators, right? There's something somewhere that's going to give you a story about why it's going to, this is going to happen or something else. So, the more information you collect, the more sense you make out of it, the better you're going to predict some of the performance issues, right? And by the time the user calls, then you might have had the problem for hours, sometimes days, right? I personally, if I don't like something, I just go somewhere else. I just don't feel like calling somebody or waiting. Today everyone just complains on Twitter, which does get some people's attention, but on Twitter you only have 150 characters, so you're not going to say, well, I was trying to log in, and when checking out this item, I ran into this problem where the database was slow. Wait, how do you know about the database? So nobody's going to tell you any information about your problem, right? So this is why I need that. And so you're never going to get the context, right? And by the time this happens, it's a worm scenario, right? Everybody's on deck. It's you guys, it's the DBAs, it's your manager who's freaking out. His manager is calling him saying what's going on, right? So by this time, there's a real problem, there's a business impact, and this is where we kind of come in and help you figure things out. If you don't have anything, it's going to be all of you, some of you trying to reproduce the problem, others looking at GMX, thread dumps, logs, everybody running around, right? So, one of the things that we do, and I encourage you guys to check us out for those who haven't seen us, is basically tell the story of the transaction, right? How does it start from a user click? How does it percolate across all the different components? Tell you the line of code that was being executed at a point in time on that specific server, down to the database call that was executed, down to the query that was being executed. So you have the full traceability of that distributed transaction, and you figure out exactly where the problem is. And collect metrics. Collect all the metrics about the threads that I said, number of threads, how many garbage collections, time of garbage collection. So that when you look at performance problems, you can eliminate these top 10 or top 8, right? And then you focus on the real problem. It could be something more difficult that we can't help you solve, but at least we'll, someone says, one of my favorite quotes is like, money doesn't buy you happiness, but you can buy a boat big enough to park right beside it. We're not going to solve all your problems, but we're going to get you close enough so you can have the right tools so you can go and solve it, right? And really, no tool is going to replace, or no process is going to, replace you guys. I've been proven incorrect many times. My job is to bring you the information and get your help to help me help you, kind of thing. And really, at the end of the day, do you guys really want to spend all the time trying to reproduce problems, get tied down in those meeting rooms? You want to innovate. That's kind of what I'm passionate about. In my space, I like to innovate application performance. In your space, it might be something else. So I just want to leave you with the fact that this ebook, it's completely free. There's one copy left, hard copy. But if you go into this website, it's basically info.appdynamics.com, and it's top 10 Java performance problems, with all the capitals there, _ ebook, and you can get the book for free. Yeah. And finally, I'm here because AppDynamics, pays for my for my presence. So it's go and download it for free, and you don't have to spell my name. So that's a bonus. And it's available for free. You don't have to pay anything. It's great with limited features and all, but whatever. Any questions?
So what's AppDynamics doing from a Polygon programming perspective?
Polygon.
Polygon, like Java and...
Oh, yeah, good question. So Java, PHP, .NET, Node.js. We've got Beta, C++, and Python.
And SQL.
Huh? Oh, yeah. Oh, I mean, databases, it's like, all the SQL things like DB2, Oracle, MySQL, Postgre, Sybase, what else did I miss? Oh, Cassandra, MongoDB, all of those. And if you have a backend that may not be discovered out of the box, let's say Documentum, oh my goodness, I keep running those guys. I used to develop for them when I was an internship. My apologies on that too. But you can just define that custom exit point so you can track the execution time, the contents of that message. So all of that can be actually tracked.
And Python's available today?
Python, give us a couple months. Yeah, I think it's now like undergoing final testing, and the next one we're going to complete is going to be Ruby. Yeah. Yeah.
Is it inspired free to analyze thread-dumps and garbage logs? Is it free to
analyze thread dumps?
Yeah.
Well, BI. No, I don't know. I really don't. When you talk about thread dumps, code deadlocks, you should get AppDynamics because it tells you exactly what the two threads will start at. And it's free.
I can give you an advice. Check Eclipse MAT, memory analysis tool. It's very good.
what's the name?
Eclipse MAT, memory analysis tool.
Awesome. Question?
And actually the same area. You mentioned something that looking at the heap dumps is extremely painful, but I can tell you that it's probably one of the fastest ways to find memory leaks, because a lot of times memory leaks are associated with code which is not yours. It's some cache setting which retains for too long, or some bytecode annotation which causes leaks for objects retained indirectly. And using, for example, Eclipse MAT, once you get the heap done, you can identify both size-wise dominators and count-wise dominators within minutes. You can, and then you can just propagate that particular set of objects in the GC tree all the way to the GC root, and then you'll know all the collections which retain it, why, so you can see soft references, weak references, why everything is not being held up. It's probably the fastest way, from my experience, to get rid of your keep leak problems.
Yeah, I mean, we monitor that, sir.
And typically you can compare snapshots.
Right.
So you can take a snapshot, then run through your code and reproduce your shoot. Take another snapshot, do it again. Basically, most performance profilers will like to do that. And then you can see, oh look, this number of objects went up, and then you can backtrack to the heap to see what's actually happening.
Yeah. And I mean, the final 10% as usual is, to actually use what you do. I mean, if I tell you the line of code where you're stuck and there's a problem, I'm going to tell you the line of execution, the method, and all that, but do I know what's inside and who wrote and what you're doing there? No, but I'll tell you 20%. Here's the problematic piece of code. Here's the surrounding information about it. Here's the transaction, the use case that led you there. And then I'm going to tell you that's a line of code. But you can open up Eclipse or IntelliJ or whatever you use to actually go and actually figure out the problem is. That being said, I mean, we do analyze collections, right? But we do it in real time in a production environment, so you can actually see it before it falls over, right? So, unless you're going to, force a heap dump on, like a 32 gig giant application, before you get there, you can use our tool to actually show you the number of collections, large collections. Look at indicators, right? And it might not, tell you exactly that there is a memory leak, but it'll get you, maybe 80% of
Are you instrumenting allocations?
Sorry?
Are you guys instrumenting allocations?
Yeah, we're basically what we do is we use some Python instrumentation. In order to add us to Java, we pass the Java agent parameter. So we do some Java instrumentation. In that case, you have to enable the flag because we're designed to run in a production environment. So we need to maintain the overhead very low. So we do some Python instrumentation, some secret sauce to understand the line of code execution, and then you can enable flags like memory collection, which will basically look at large collections, like large kubelet collections, and then basically look at them every 10 minutes and see if they're continuously growing and give you at least a wet finger estimate that you may have a memory leak, in which case you use your average tool set to determine what it is.
How does your overhead compare with Java Flight Recorder with respect to allocation tracking and stuff?
With that specific, I don't know. That I'm not sure about. Yeah, but in terms of usually when we enable that from our from our calculations, we usually add 5%. Typically, we run at a maximum of 2% overhead, right? With everything enabled, that's why we're designed. We're a production tool. You can enable a pre-production mode, which then blows it up to whatever it needed to understand all the different transactions. But typically, it's less than 2% overhead. When you add those additional things, we've experienced 5% or more of overhead on top of the 2%. So the real number, I don't really know. It's kind of hard to calculate, and I don't know how we compare specifically to that.
Thank you.
Thank you very much, Nick.